Alright, so a couple of weeks ago I bought this guy here. This is a Axisflying 256 thermal FPV camera. And I've already done a video about this. If you haven't seen that, you should go and watch it. But basically this is a proper thermal FPV camera. It can't see visible light at all. It can only see heat. It is a proper thermal FPV camera. Now, in the previous video, I showed me kind of playing around with the camera quite a lot, but that was entirely just on the ground. But obviously, with it being an FPV camera, the goal was to put it onto a drone, put it into the air. And that's what we're going to be doing in today's video. So what you see here is my Heewing T2 VTOL P&P aircraft. And I've installed the camera in the nose here. Now, I'm going to show you in a moment kind of how I installed it and sort of some of the wiring and stuff, because it's a little bit complicated to do. And I think some of you guys might be interested to see that. But before I do that, I just want to explain to you why it is I've chosen to put it on this aircraft versus any of my others. And the main reason for that is basically because the Axisflying 256 thermal camera has got a very narrow field of view. I think if I remember rightly, it's got a 9.7mm lens with a 18-degree field of view. It's basically a very narrow field of view, which means you can't really use the camera as an FPV camera. In fact, I did try it a couple of weeks ago, and it's very, very hard to sort of navigate your aircraft through the air using that camera, just because you've got such a narrow field of view. So basically what I've kind of concluded is that camera is not really designed to be used as a normal FPV camera as such. It's designed to be used as sort of like an additional camera, so you can kind of have a look around, but not whilst the aircraft's sort of flying, if that makes sense. Basically, I think that camera makes perfect sense if it's going to be used on board a quadcopter, like a GPS-enabled quadcopter, which can just hover in place in the sky without really moving around. And you can then use the camera to kind of look around with that. But you then want to use a normal FPV camera to actually navigate the aircraft. So long story short, that's why I've used this aircraft here. Because this is a VTOL aircraft, I can take this off and then I can just hover it at a fixed point in the sky. And then I can use a thermal camera to have a look around. I don't need to use the thermal camera to kind of navigate the aircraft. I can literally just use the thermal camera to have a look around, and then I can use a normal FPV camera to navigate the aircraft if I want to. Hopefully that makes sense. So anyway, let's now have a look at the aircraft. So this is a Heewing T2, like I already said. And the good thing about the Heewing T2 is it's got a removable nose, which means you can then put your own noses on there that you want to. So this is one that I've designed and 3D printed myself, and I'm pretty proud of it because it's come out looking pretty nice. And if we look on the inside here, hopefully you can see, there is the Axisflying 256 thermal FPV camera. Now underneath it, there is a second camera. This is a standard visible light camera. This is a Runcam Phoenix 2. And this will be the main sort of like flight camera that you'll use to sort of like navigate the aircraft during flight. Now because there are two cameras here, I have used a video switcher, which we'll talk about a little bit more because that's down in the back of the aircraft. But basically, yeah, I've got the option in flight to kind of switch between these two cameras so I can choose which one I want to use. Now, as I said a minute ago, the goal is going to be to sort of like take this aircraft up in the air and then just hover it at a fixed point in the sky. And then I can switch to the thermal camera to then kind of have a look at whatever I want to have a look at. Now, to make that a little bit easier, what we have here is a TowerPro MG90S metal gear servo. And this is being used as a tilt servo. So what I can do is I can adjust the angle of these cameras whilst I'm in flight. That means if I got the aircraft hovering and I see a target on the ground I want to have a look at, I can then just aim the camera however much I need to have a look. And if if the object is moving, I can adjust the tilt angle here. And then if I want to obviously yaw the aircraft left and right, I can do that to make sure that I always maintain keeping the camera locked on what I want to have a look at. Like I said, I designed all this myself and I'm really happy with how well this has all come out. But I am interested to see how well it actually works, in flight. So yeah, so two cameras in front and a tilt servo there. Now to actually get this working on this aircraft was a little bit complicated. And I'll show you inside the aircraft now, so hopefully that you'll understand. So this was a P&P version of the T2. And what that meant is it came with this flight controller here pre-installed. This is the Heewing FX405 flight controller. And this is a very good flight controller. I've got no complaints about it. It works absolutely fine. The only problem is that it comes with, I think it's 8 PWM outputs on the flight controller. all of them are occupied by the various sort of flight control surfaces on the aircraft, so you don't have any spare. The reason why that's problematic, hopefully you can kind of work out what I'm getting at here, is that if there's no spare PWM outputs on the flight controller, how do you control the tilt servo in the front? Well, what I ended up doing was end up buying this guy here. So I fly with ELRS, and I normally use these the standard like Crossfire style ELRS receivers. Basically just a standard receiver that has sort of like 4 wires going out, power ground, and then TX and RX wire. But what I've done on this aircraft now is I bought this receiver here, which is a Radiomaster ER6 PWM receiver. Now this still outputs Crossfire over a UART. It's coming out the back here through this cable here, which is then connected to UART1 on the flight controller. That's basically the same as what I had before with my original ELRS receiver. But what's different with this receiver is it has actually got 6 PWM outputs. So what this means is I've basically been able to extend the amount of outputs that I've got available to me beyond what the flight controller has. I now have 6 additional outputs. And hopefully you can see here on channel 1, I've got a cable coming out of here, and it goes down underneath the battery to the front. That is the PWM output, which is controlling the tilt servo. So it's bypassing the flight controller. It's coming directly from the receiver. So on my radio, I've got a scroll wheel. And as I move the scroll wheel, it just sends a signal straight through channel 1 here, which I think for my setup is output 8. Not that it really matters. But anyway, yeah, it sends a signal out of there, down through the front, and that's how I control the tilt servo. And that works really well. I say it's a little annoying, obviously, having to kind of replace replace the receiver with this bigger one here. But actually, I think for sort of like future-proofing, this is a good idea, because now I've got additional PWM outputs. You know, if I decide I want to put a gimbal on the aircraft, or, you know, if I want to use the flaps or whatever, you know, it gives me future-proofing options. Now, the only thing I just want to mention about this was it's a little bit annoying to set up, because so this wire here, which is the sort of the Crossfire communication protocol wiring, this will provide enough power to the receiver to allow you to obviously use it. But if you want to use the PWM outputs on the front here, you have to provide an additional 5 volts. There's a port on the receiver there called BAT. You have to provide 5 volts to there as well, so you can then use these PWM outputs. It's not a big deal, but it's something that did catch me out at first, and it's just an annoying step that you have to do. So yeah, I had to install that receiver to get this all working. Now, the other thing, obviously with there being 2 cameras down here in the front, I needed a video switcher. And that is what this little guy here is. Hopefully you can see that. So this is a ViFly video switcher. So this can take 2 separate camera feeds, and then you can switch between the 2 camera feeds using a switch on your radio. Now, this is another reason why I needed a receiver, because I also needed an additional output to be able to control the video switcher. And hopefully you can see it there. That's on channel 2. That's literally just a PWM wire that's going out to the ViFly video switcher. And that then allows me to, well, as I'm flying, just flick a switch on the radio, and I can switch between the 2 video feeds. So yeah, so that was basically everything I had to do to kind of get this all set up. It was a little bit annoying. If I'd used sort of if this aircraft had like a Maytech flight controller in there, I probably wouldn't need to do any of this, because a lot of Maytech flight controllers have a video switcher built in, and they also have a lot more like PWM outputs normally going spare. But yeah, if you're using the PMP version of the Heewing T2 VTOL, these are kind of the steps you need to go through. But it wasn't particularly expensive, and it wasn't particularly complicated. And I'll put a wiring schematic on the screen, so if anyone wants to kind of copy this, they can do that. So yeah, so that is what I've done. This is how I've set this up. So I now have, for the first time in my life, a fixed wing aircraft that's got a thermal FPV camera on there. So what I'm going to do later on, I'll wait for it to get a little bit dark, because I think it makes sense to kind of test a thermal camera in the dark. Yeah, wait for it to get a little bit dark, and I'm going to take this out for a flight. And yeah, I'm not going to be flying this as a fixed wing. I'm literally going to be taking this up in the air, and I'm just going to be hovering it, just so I can kind of have a look around at the world from kind of like a fixed position in the sky in thermal, in infrared. I won't be flying as a fixed wing at all. Literally just going to be doing some hover testing. So yeah, basically got to wait for it to get dark now, and then yeah, we'll see how it goes. All right, so it's a couple of days later, and as you can see, well, you can't see, I'm in the middle of a very dark field, and the moon is out. It's about an hour and a half since sunset, so it's probably about as dark as it's going to get. And down here on the ground, hopefully you can just about make that out, there is my T2 all ready to go. And I'm in a field that's on kind of the outskirts of town. So the city, well, I'm pointing my hand, you can't even see it. The city is kind of the direction that the camera's facing. And then behind me in this direction, mostly kind of like hills and fields, but there's a couple of sort of buildings and stuff over there. But yeah, hopefully it's been an interesting location to kind of check out with the thermal, because there's a couple of busy roads nearby. There's a supermarket just in front of me, and there's a park just over there as well. So there should be some people walking around. So, I'm going to get the aircraft up in the air. Like I said earlier, this is just going to be me hovering the aircraft. I'm not going to be flying as a fixed wing. I'm just going to be hovering it, and then we'll have a look with the thermal. Now, I should just mention before we get started, I have actually done 2 flights already with this aircraft on different evenings. And they worked okay, but I did have a couple of problems. Just issues with the tilt servo not working properly, and also an issue with the video switcher. But I decided to just do a whole new flight and kind of narrate this one as we go. But I am still having a problem with the video switcher, but you'll see that for yourself in a little bit. But anyway, let's get this aircraft powered up, and let's get it up in the air. All right, so the aircraft is all powered up and ready to go. Hopefully you can just about make it out there. I know it's a bit too dark to see the aircraft, but hopefully you can see the navigation lights. So yeah, let's arm the aircraft, and then I'm going to just take her straight up above. I might move her forward a little bit, because otherwise I'll be stuck in the Fresnel zone of the FPV signal. But yeah, she's going to hover just above overhead, and then we'll have a look and see what we can see. So let's start off with arm the aircraft, throttle up, and there we go. Let's take her up. Probably go up to about 50 meters or so. So it's about 27, 30. Take a little bit higher. Let's get her up to sort of around 40, 45-ish. So we'll stop there. Try and hover her. So it is quite hard to get this aircraft to just hover on the spot. But now if I show you, so I can move my main FPV camera around, just using that slider on my radio. And if I want to turn left and right, I can just yaw the aircraft left and right. So move the aircraft forward just a little bit, so it's not directly overhead. I think actually the most interesting thing I could do to start would be to just have a look at myself. This might be tricky, because I see it's very dark. Hopefully you can see that little light there on the ground. So that's the light coming from my radio. And what I'm going to do is I'm going to switch to the thermal cam. It's going to mess up a little bit. Enabled. I don't know what's causing this. It's not an NTSC power issue, because I corrected that. For some reason this camera just won't switch smoothly, but it will eventually do it. And there we go. So there's a thermal view. Where am I? It's quite hard. There I am. See me there? Waving. So that is the thermal view. Looking at me. What am I? So I'm about 80 meters up. Need to reduce the throttle a bit because I am climbing. But yeah, as you can see, amongst this dark ground here in the pitch black, I'm glowing very, very brightly. So this white bit here that you see glowing really bright, that's actually a little stream. It's crazy how much water glows. It looks like a river of lava, doesn't it? Oh look, it's surreal. And that's literally just a stream. Apologies for the FPV signal cutting out a little bit. Yeah, that's surreal. Just look at this little stream here. I don't know what this rectangle is here that's glowing. That's interesting. Here we are looking towards the end of the field. So we've got a path here. It's crazy how much paths, or just tarmac, just glows here. It's interesting, there's a very warm patch right there in the middle of the field as well. Let's switch back to the standard view a minute. Yeah, no idea.
Enabled.
Oh, it switched perfect that time. No idea why there's a warm patch in the field there, because this is just an empty field. No idea what's causing that. So here we've got a like a little sports ground. So that's like a little tennis court, I think, or maybe a small football pitch. And you can clearly see the people there. Look at that. Let's go back to the standard view. So you can't see anything in the standard view because that little pitch is very well lit. So well lit that the camera can't make them out. But
Enabled.
yeah, in the thermal, look at that. You can clearly make out the people. Some more people over there as well, by the looks of it. Very cool. So what else have we got to look at here? Right, so here's the supermarket I told you about. This is the car park. There's some people there walking in and out of the supermarket. And yeah, isn't it interesting, look? So there's a car driving in. It's interesting, you can see the car tyres are clearly glowing. The car's obviously been driving for quite a while, so the tyres are quite warm. Go around a bit more. I do find it surprising how car bonnets appear black. You'd think with the engine being underneath the car bonnet, that would be the part of the car that would glow the most. But like I said, I've been using this thermal camera quite a bit the last couple of days, and every car I've seen, or almost every car I've seen, the bonnet always looks black, which I find very, very strange. But yeah, look at this, you can see people walking around over there. So that's the main road there. That's someone walking past a bus stop there. So one thing I should mention, so you can probably see that the camera is waggling a little bit here. Now, it's actually not waggling as much as you think. Like, the aircraft is obviously just making small adjustments in the air. There's a very, very slight breeze, so the aircraft is constantly adjusting. But because this lens is quite zoomed in, quite telephoto, it magnifies the effect of a small movement to make it look like quite a lot. So unfortunately, there's not a whole lot you can do about that, other than maybe use a gimbal, which we'll talk about a little bit later. So I'm now looking sort of further into the distance, it's a couple hundred meters away. You can clearly make out cars moving. So one thing I need to remind you, this camera can only see infrared. It can't see visible light, so anything that you can see on this camera is a heat signature. Now, one thing I've noticed, I'm guessing it's a cyclist, because this person's moving very, very quick. Yes, that is a cyclist. Yeah, you can make out the edge of the shape of the bike there. Yeah, one thing I've noticed with this camera, probably not surprisingly, is that the effectiveness of the thermal, or its ability to detect heat, does diminish with range. So here I am now, I'm kind of looking off into the distance across the city, and you can make out much less details. Now you can still make out some details. I mean, there's a building in the far, far distance over there. I can see it, it is glowing a little bit. So you can pick up heat from a long way away, but kind of at a distance, only the hottest objects can be picked up. So like, yeah, being able to pick up a person from the experimentation I've done the last couple of days, a person needs to be within sort of about 500 meters. I mean, there's a person there. I'll have to measure this when I'm on Google Earth later, but I'm going to guess that's probably about 250, 300 meters away. You can make them out, but you probably wouldn't want to go much further away than that. Look at this though, isn't this just really cool? Isn't it just the coolest? Let's have a look over in this direction, because my car's over here somewhere. Where's my car? There's my car. You can tell it's my car because it's glowing, because I've literally only just pulled up a couple of minutes ago. And yeah, I mean, I know the bonnet's glowing quite a bit there, but still, you can kind of see what I mean. Car bonnets don't glow anywhere near as much as the rest of the car. I do wonder if they put some kind of like thermal insulation in car bonnets or something. So there's that stream on the right hand side there, just following that into the distance. And then yeah, looking off into the far distance there. I mean, you can make out buildings, not in great resolution admittedly, but you can make out buildings for sort of several kilometers into the distance there. Very, very clearly. Panning around sort of the whole city here. And yeah, clouds as well. I can't look up any further than that, but yeah, it's interesting to see how clouds actually kind of have a bit of a thermal signature as well. I guess that's not surprising really. I mean, clouds are made of water which is kind of evaporated, which means they have to have a bit of warmth in them, don't they? But yeah, isn't this just the coolest? I feel like I've got myself a proper little SAR drone, search and rescue drone now. And yeah, hopefully you can kind of sort of see from the bit of video at the beginning here, it is very dark here. You know, if there's a person in this field with me, I wouldn't be able to spot them. And here's an interesting thing as well. Look at these trees. This is quite a forested area over here. And it just sort of looks like I'm looking at a cloud, really. Can't really make out any sort of definition amongst trees. It's just sort of one big uniformly white area. Looks quite ghostly. I do wonder, because in these fields here, you do sometimes get animals. Just wonder if I can see any. It's interesting how that tree is glowing so much brighter than any other tree. So this is interesting. I don't know if you can make this out. So there's a tree there with a dot that's glowing in the top of it. So that's not actually a tree, that is a radio mast, a radio antenna. But they've hidden it, they've disguised it as a tree. And to the eye, it's very hard to make out that that is a mast. But yeah, in the thermal, you can clearly see that there's some power running through that. That's quite interesting. Not seeing any animals, unfortunately. I was kind of hoping I would. Just scanning around a bit here. There might be a couple of animals there, actually. It's kind of hard to tell, but it's very much definitely a glowing spot in a field there. You normally get cows and sheep. That could be a cow or a sheep, couldn't it? Very interesting. I'm kind of in the Fresnel zone again. Let me turn back around. Try and get my bearings here. So my car's over here. Yeah. Interesting as well, on the edge of this field here, there's a load of boulders. It's interesting to see how much those boulders are glowing, isn't it? Let me just go to standard view. So this is what the Phoenix can see. The Phoenix is a pretty good low light camera, but obviously it cannot see anywhere as near as much detail as a thermal. And you can't see those boulders, can it? You see what I mean about sometimes the video switch is a bit glitchy. It doesn't switch straight away. I haven't been able to figure this out. Sometimes it works fine, other times it doesn't. It's very odd. It's interesting looking at houses as well. It kind of surprises me how houses always sit up here to glow, but the roofs don't. The reason why it surprises me is because you'd think that obviously with heat rising, the roof would be the hottest part of the house. Now, especially as well with obviously during the day with the sort of the sun beating down on it. You'd also think it'd be the hottest part of the house, but pretty much universally, rooftops always seem to be the coldest part of a house. And it's got something to do with all the insulation that they have in the house. And there's an interesting thing as well. You can see that in the distance there. Solar panels. Over the last couple of days I've been playing around this camera in the dark. I've noticed that solar panels always are appearing black. They don't emit any heat at all. I guess that's got a large part to do with how well they work. Absorbing sunlight, absorbing the heat as well. It wouldn't work very well if they radiated heat, would they? Let's look down the road into the distance a bit, see how far we can see. So you can make out cars quite clearly a long way down that road. The details do start to sort of blur together though. Sort of gets hard to make out sort of what you're looking at after a while, but I'd say at this point the houses I'm looking at there are probably about 1 kilometre away. And yeah, it's probably about the limit of what you can sort of sensibly make out details with. So the car's here, going around a roundabout. I find it interesting, you can kind of tell how long a car's been driving for, based just on how warm it is. I mean, this black car here, sorry I say black car, but this car here, it's not radiating anywhere near as much heat as some of the other ones I've looked at. So you can kind of tell that car's only recently started its journey. Whereas this one going off to the right here, its tyres are glowing quite warm. So you can tell that one's been driving for a while. I do find this stuff really interesting. So yeah, this is the Axisflying 256 thermal FPV camera actually being used on a drone. And as you can see, works pretty good. I do enjoy flying with this. It actually works pretty well. Hopefully you can appreciate what I mean now though with the narrow field of view. So actually what I'll do, so there's a fixed, there's a visible spectrum shot. I won't move the camera. And then if I switch to the thermal camera, so what I'll do now is I'll overlay the thermal camera over the visible camera image. So you can kind of see how narrow the field of view is with the thermal camera. And that'll give you an idea why it is that you can't really use this camera as a primary FPV camera. The view is just too narrow. But for something like this, where you're not using it as your main camera for navigation, but you're using it just to kind of have a look around whilst your drone is kind of hovering at a fixed point in the sky, this works very, very well. And I think this is a perfect use case for it. Very cool stuff, right? Very cool stuff. I was kind of wishing this would be like, I don't know, some people or animals walking around this field. It is really weird. Look at these glowing patches on the field here. This is literally just a grassy field. But there's these glowing patches. I mean, there's a very big one here. And like these here, they're almost like structured, like straight lines. I wonder if there's like something, I don't know, buried under the ground. I don't know what that there is either. But yeah, it's interesting. You can see these features glowing in the ground that you can't otherwise see. So actually that kind of circle there, that could be the centre of a football pitch, couldn't it? Maybe I'm kind of seeing the paint markings for the football pitches. I bet that's what it is. Interesting how that glows differently, right? So yeah. Anyway, I am rapidly running out of power here. So I'd probably better land the aircraft. So I'll bring her down very slowly. Pick my GoPro up so we can film the landing as she comes down. I'll pitch the thermal camera back up as well. So here we are, coming back down again. So I'm currently using a, what is it, a 7,800 milliamp 6S LiPo battery on my Heewing T2. That battery was very kindly sent to me by Heewing to play around with. And I'm actually very impressed with that battery because, as you've seen here, in like purely just in hovering mode. So I've just done just over 16 minutes of flight. And the other day, I managed to do about 19 minutes. I think for an aircraft this big and this heavy, I think 19 minutes of flight as a VTOL is actually really quite impressive. Just realised you can't actually really see the aircraft here, can you? Almost landed. And we're on the ground. And disarm. I did land a little bit away from where I took off. That's because I'm trying to operate my radio with one hand. And it's easier to just descend the aircraft than try and sort of reposition it as well. But yeah, there you go. One successful flight of my Heewing T2 in the middle of the night, in the dark, using the Axisflying 256 thermal FPV camera. Very cool stuff, right? Very cool stuff. Okay, now before I end this video, I think there's just a couple of things that are kind of worth talking about. And the first one of the things is going to be the price of the camera, because I know there's people out there that are going to ask. So the camera is listed as costing $220 on the Axisflying website. That translates to roughly £170. However, that isn't actually the price that you're going to pay. What they don't tell you is that you get stung for import tax when it arrives in whichever country you're in. I ended up paying £50 worth of import tax, which meant that the actual price I paid for the camera was around $295, which is £234. I think that's just something that's kind of important to mention, if you're interested in sort of buying this camera for yourself. Now, the next thing that I want to mention is the fact that on the Axisflying website, they actually sell 3 different versions of this camera. They sell the 256 version, which is what I have, a 384 version, and then a 640 version. Now the 640 version is the higher spec version. Yeah, it's got much better sort of specifications, but it's also the more expensive version. It costs $680, which is around £525. And of course, that's not including import tax. Now, even though it is the more expensive camera, I think if any of you out there are sort of interested in doing a project, similar to mine, if you're interested in getting into sort of like thermal FPV, if you can afford to buy the 640 camera, I absolutely think that you should. And the main reason for that is because the 640 camera has just got a much wider field of view. As you saw in my video, the field of view on my camera was very, very narrow. It's got a 9.1mm lens and a 18-degree field of view. So it was a very, very narrow field of view. It did work, as you saw, but obviously having a wider field of view is always going to be nicer. The 640 camera has got a 9.1mm lens and a 48-degree field of view. So still kind of a narrow field of view, but it's more than twice as wide as the camera that I'm using. Another reason to buy the 640 camera as well is it's also got a higher frame rate. It can do 50 frames per second, whereas the version I've got can only do 25. Obviously, it's entirely up to you, but I'm just saying, if you can afford to buy the more expensive camera, you're probably going to get a nicer experience for using it. Now, as you saw in the footage I showed you a minute ago, I did have success with having the Axisflying 256 camera on my Heewing T2. However, I think that if you're interested in sort of doing a similar project, it would make way more sense to install that camera onto a GPS-enabled quadcopter. The Heewing T2, the VTOL version that I've got, obviously, as you saw, it is capable of hovering, but it's going to be very inefficient. It's an aircraft that's sort of not really designed to hover. It's a fixed-wing aircraft. It's designed to sort of fly like a fixed-wing aircraft. The hovering is a bit of a gimmick, but it's going to be very inefficient. If you were to put the Axisflying 256 camera onto an actual like GPS-enabled quadcopter, it's going to be way more efficient. You're going to get much longer sort of flight time. I think you're just going to get much better stability from an aircraft like that. I think you're just going to have a much better experience. And sort of talking about sort of like stability as well. So like you saw in the footage I showed you a minute ago, I mentioned it like, the camera was kind of like wobbling around a little bit. Obviously the aircraft is sort of always making small adjustments, especially if there's a little bit of wind, and having the telephoto lens on there kind of like magnifies the effect of how much the camera's moving. Doesn't look particularly nice. So I do think that actually using a gimbal with this camera would be a good idea. Now I've got a Caddx GM3 gimbal here. That's a gimbal which is very much designed to be used with the walk snail system. But just out of curiosity, I had a look to see whether the Axisflying camera would fit that gimbal, and it does. However, the gimbal doesn't have enough power to actually lift the weight of the camera. Now I know that HEQ makes some gimbals which are a little bit bigger and probably a little bit more powerful. So one of them sort of might be a good option. But if not, a gimbal that's designed for a GoPro, something like a turret gimbal. They've been around for years now. One of those would probably be a good idea. It'd probably have more than enough power to be able to sort of lift up the Axisflying camera and your standard FPV camera as well. And I think that just having a gimbal would just, make using the camera a little bit easier, and you're going to get nicer footage out of it as well. It'll get rid of those slight little wobbles to the left and the right. So yeah, that's just sort of an idea for you guys, and it's something that I might sort of look at doing myself in the near future. Now, talking about the near future, so there is a feature of the Axisflying thermal cameras that I'm sort of keen to investigate, and that is the fact that apparently they can also do colour. So as you saw from the footage that I showed you, the camera is in sort of black and white mode. It's white is showing hot, black is showing cold. And that is how the camera arrives to you by default. But it shows in the instruction leaflet that comes with the camera that actually it is possible to change the camera to do different color modes. So you can have black is hot, white is cold, and you can also just have like a full color setting where like different colors represent different temperatures. Now obviously I'm very keen to kind of like play with that. However, over the last week, I've spent many hours trying to get that to work. And the way you're supposed to do it is you're supposed to connect the camera to like a FTDI adapter or like an Arduino, and then use a special bit of software to kind of communicate with the camera, and then you can send some codes which should do the reprogramming. I spent a lot of time over the last week trying to get that to work, and I've sort of used ChatGPT quite extensively to kind of guide me through it, but I haven't had any success. Now, one of my subscribers, a guy called Dwayne, I hope I'm pronouncing your name right, he reached out to me, and he's bought the 640 version of the Axisflying camera. And he's got some different hardware. It's not an FTDR adapter, it's some kind of different hardware that I think he makes himself. And he's reported to me that he's actually successfully managed to interface with his camera, and he's actually managed to sort of change the color palettes himself. I think he's planning to post a video on his YouTube about that, and if he does, I'll post a link down below so you can have a look. But I also believe that he's planning to send me the whatever hardware it is that he uses. He's going to send that to me with some sort of special software on there. So then hopefully I can then also reprogram my camera to do full color mode. If I manage to do that, I'll do a video showing not only how I managed to do it, but also kind of demonstrating what the camera actually looks like when it's in full color mode. I think the camera will be much nicer to use in sort of full color mode. And I think that'll make a really interesting video. So yeah, hopefully at some point in the near future, I'll be doing a video like that. And I'm also planning to just do some sort of like more night flying. Looking at the world in sort of infrared and thermal. So yeah, that's basically all I've got to say now for this video. But I hope you've enjoyed watching it. I hope you found it sort of like interesting, and I hope I've inspired some of you guys. And yeah, as always, if you enjoyed watching this video, please do give it a like down below, and I'll catch you in the next one. Cheers guys, bye.